How do I make this center? Yeah, it should be fine. How do I make this center? Okay, great, I can hear myself. Sound like last time. We have a mic problem. We have a guest problem. Someone visit my, it's not my home, my aunt's home, and then gotta cancel the entire stream because of that. Now I'm back. I made a few adjustments to the random library that no one gonna use, and I want to take this opportunity, maybe explain a bit about neural network, and maybe show the application of the library. I just spent my 3 years of my life building it. I'm not sure where to start. I don't have any agenda today. It is 1 hour left before I have my first online class for this week, so we gotta get going. Before we do anything, I think I want to install this graphing library for C++, because we want to visualize stuff. So bear with me. Turn something off. So I'm not sure how I'm gonna do with it here. cd test, cd lib, and now I gotta git clone that. Hopefully we can use it, because I hate CMake so much in C++. This is the only time I'm gonna write stuff in C++. Hopefully I'm not going to do anything in the future. Okay, we got there. So we gotta somehow add the new library into our things. I'm gonna create a new file here. Let's call it stream, and then to make sure that IO stream using, and by the way, I just bought Copilot, which is very helpful to write stuff. Boom, see that? That's the power of Copilot. Gotta go back here. I know this is not the right way to test stuff, but it's my program, so shut up. No one watching anyway, so. Make run. Okay, we got a hello world, so we need to somehow include this thing into our program. God, I hate this so much. How do I? Where's CMake? I saw it somewhere. Come on, yeah. Wait, I think I actually use it in one of my projects, so I can just copy it from there. Source. Yep. So I have that thing over there. I can just add the sublibrary. What is it? Add subdirectory. I'm gonna add it sub. Perfect. This is awesome. Matplotlib CPP. It's funny how they call it CPP. Doesn't mean I want to CPP or anything. It's just there. No flow in matplot. Compile this one more time to make sure that the okay. This is great. Which is not exist. Okay, I understand. I'm sorry. Lib. Icon 3 is not found. That's hurt. What is that? Oh my god, what the hell is that? I gotta delete this and then do that. Copy this instead. We're not getting into my things yet, so okay. I think I got it. So we add the matplotlib++. No, not this one. This one. I think it's better if we. Oh my god, damn it. So if I go to here, maybe. I'm so confused right now. Okay, yeah. I'm sorry for those who are watching in the future. I don't understand my own file structure because C++ is horrible. Okay, now I got that thing in there. Gotta go back, gotta go to source, go to this thing, and then add the third party thing, and then I'm gonna add subdirectory. Perfect. Not that. I wanna add matplotlib CPP, and then I'm gonna add it in here. Awesome. Close that. Open this, and delete this thing so that, oh no, it's supposed to be like a, oh no, not again. What? Configuring incomplete. Matplotlib C++ does not exist in directory. Where are you talking about? Oh, third party. This one. I do. Oh god, what was in the water today? Did I put something in there? Good water. Anyways, it's getting boring for the stream, so I'm gonna put some Minecraft parkour again like last time because I've seen it. Oh, here's me. Let's go. Minecraft parkour. Yeah, I've seen the retention of my stream kind of go up, so here you go. Those short attention view out there, I'd enjoy it. Oh, I gotta Minecraft soundtrack too. That's great. That's awesome. I'm not sure if everybody can hear it, but yeah, that's relaxing, you know. Matplotlib. I hate linger errors so much. Now this music kinda getting loud. It's gonna make me cry. Oh, okay, I see what's going on in here. It close everything so that my brain doesn't go bruh mode. I already include IO stream from the headers. And then copy one of the example and see if it's going to work. No, not going to copy. That's for wait, no. I do have to copy. Oh. Yep. No more hello world. I'm gonna use the namespace. Oh, this is awesome. Okay, everything seems fine. Oh, would you look at that? Then where to get this ren from? There's some mysterious C++ stuff. No such file directory. Bruh. How did I even do that like a month ago? I don't know, my brain worked differently in the past. I'm gonna have to follow the secrets.h. I did include it here. It's just matplot. Well, congrats myself. Gotta. It's so dumb at that. Okay, try again. Oh my god, what is going on? Do I really need to do this? Do. 3D function, what the hell is that? It didn't. Oh, what? Yo, this is cracking my head. I thought it would be like a quick stream. I can just get in and do my thing because it worked a month ago and now it didn't work. The matplotlib didn't work. What is this? I'm gonna go back, not include anything, and hopefully I don't think it's gonna be a copyright for this music, right? I'm just asking myself because no one answering anyway. But now it's feeling kind of weird talking alone. Anyway, node flow target include which require matplot that is not in any export set. It's interesting. Not that I know how to solve it, but it keep repeating the matplot. But maybe I'll have to do something about this. I have to check this maybe. It's called matplot plus plus. Where is the alias? There's no alias. So I gotta include that instead of matplot this, whatever this is. And hopefully that will make it work. Okay, it does seem to work. Cannot open files. File matplot++.lib. Oh my god, bro. Anyone know how to solve this goddamn problem? Do I need a graph? I just copied this from my old project, so I suppose it can just because icon is also there. Maybe I have some other secret sauce somewhere. I didn't put it in. No. This one maybe. No, it. Apologize for the inconvenience. Oh. Oh no, I still don't know what I'm doing. Use find package this one instead. Where's the .lib? I should have searched matplot libcpp install. Extremely simple, indeed simple, but I couldn't get it to work. Not sure what's going on. Does this thing use Python? There's no way to use Python. Damn, it look fancy. couldn't get it to work. What am I doing? Let me try the old project if it's still working. It is still working. What is that model I'm building over there? I suppose that is a different model. Yeah, it still uses the old Noteflow function, Noteflow classes. It's not a new one. I add this in here. I also add it in here. And then I just need to add it like that. I think it's because the font package of the icon 3 make it not working. Because last time should have suppose it. Boom, boom, boom. Huh? Now I'm even more confused. Very convenient. Delete this. Get rid of everything, then hopefully we can just go with our life. And now our life didn't work. New line, inconstant. Number of yeah. God. Okay. I guess we will have to ignore the graph and let not do anything. Oh, I just realized the entire time my face just block the entire code. Alright, let's just look at my self-cut hair, DIY homemade. Now I'm gonna put it up there, down there, sorry. Anyway, I got distracted by this. I'm gonna keep it in the background and let you listen to it. Anyway, I've just built something with the library which make it a lot easier to use. So I don't need to use include or anything, because I suppose, wait, I do need to use include. Wait, does that mean? Wait, is it because of, oh, I forgot to include it in here, I think. I'm gonna create something really quick and then add A, B. Oh, it would be nice if this thing support normal number like that. Oh my god. Identify not found. What do you mean? Graph. Bruh. I think I included in here. No, not a problem. If I go here, it is in here. What is going on? I just break the entire thing because of that matplotlib. Undeclared that. What am I doing? Close this. Well, let me go to one of the tests. Subgraph should be fine. Yeah, I'm gonna add this thing in here. Now I'm just confused with my life. What did I do wrong with my own include node flow, and then I don't understand C++. I don't understand programming. I hate programming. Now it worked. That's funny. Okay. So okay. Love my life so much. That's why I do programming. We compiling, we run it, we get the result. Okay, so I built this thing called the graph class. I gotta turn that off. That's horrible. Why would people on the TikTok do that? That's weird. Why, like, short and all of those stuff? Why do that? Anyway, I built this graph thing that allow you to create a graph, obviously, using simple function expression. Like, for example, if you want to add two numbers together, A and B, just type add A and B and then provide in the number. Like, what is A? It's basically a number, so I use the scalar method from the node to create a scalar, a number, and then I do the same for B. And then if I call forward, basically tell the function to evaluate that value, it should evaluate the thing on the graph, and then I can print it out, which basically give me number 2 over here. So this allow me to create complicated graph with simple expression. So if I want to, for example, use this function on top of that, I could just use it and it should work. We just need to wait. And boom, as you can see, we get the result. Now the real cool thing about it is the backward derivative. So what this graph allows you to do is that you can take the derivative of the entire function inside here. So you take the entire derivative of this function and it will take care of the chain rule for you. Basically, if I have a function, for example, sine, can you even see that? Gotta make it larger. Sine of x, when I want to take derivative of that, d sine of x with respect to x, I get cos of x. This is basically a derivative, simple math. Now, if I have a weird function, something like sine of cosine of x, which is a composition of a function inside another function. Basically, you give one value to cos, and then the result of this function feed into the sine function. Now, when I take the derivative of this function, I cannot simply write it down as cos of x, because this thing is another function. It's not a proper input. It is another function that feed into this function. So if I want to take the derivative with respect to this variable all the way down inside this function, I would have to use the chain rule. Basically, I multiply with the derivative of the inner function. So the derivative of the inner function is negative sine. Derivative of sine is cos, and derivative of cos with respect to its input is negative of sine. So that is basically what it is. Now, if I have any other complicated function, it doesn't matter how complicated it is, as long as the library is defined, the library know what the function is, it will be able to take the derivative of that and give the result for you. So now, when I call backward, I can get the respected partial derivative, because this function take multiple inputs. So it's not just derivative, it's called partial derivative. I can print out, for example, derivative of the entire function with respect to a. I can say f, I hate this, I don't like this, okay, get grad. And if you understand a bit of calculus, you know why I call it grad. I don't know why I call it grad, I forgot. It stands for gradient, obviously, but it doesn't make any sense. It should be get partial or something, but anyway. If I want to get the derivative with respect to b, oh no, I accidentally closed my editor. I'm gonna go back, edit, and ignore all the error, because the NeoVim thing I'm using doesn't understand what I'm trying to do, doesn't understand the vision over here. Anyway, it should just give you the derivative with respect to that function, respect to that variable. So I'm gonna call make and call make run at the same time, so that we don't have to waste time. You know what? I'm gonna exit this. What is going on? I'm gonna open another terminal on the right side instead. It's more clean. It's easier to see, you know. Okay, so the first thing over here is the forward. Basically, you take the tanh of add of a plus b, and you get this value, while a and b is 1. Now if you want to get the derivative of the entire thing with respect to one of the variables, you get this value. So that is what it is. So now what this thing allows you to do is, it is very convenient, very beautiful. I don't know, I'm just bragging about my own library right now. Anyway, I can create not just adding two single number, I can use matrices in this function by just define it basically. So I can, instead of using node, I can call vector, for example, and give it some number to. Oh, that would be nice if we have a infinite parameter. Now okay, now we have a vector of number. A vector is a set of numbers, so a vector of number doesn't make any sense. What am I saying? That forward dot print. Okay, and we could just, I still don't understand why this terminal stuck there. What is it? Okay, so we add all of those numbers together. So all of this, okay, I should have explained it a bit more here. A vector is basically a list of numbers. So our first vector is 1, 2, 3. 1, 2, 3. And then I have a second vector is another list of number. Make it straight. What is it? 3, 4, 5. 4, 5. And then I basically add both of them together and I get, what is it? 4, 6, 8, I suppose. I'm not good at math. Anyway, now after that I take the tanh function. In case you don't know what a tanh is, it is a hyperbolic tangent. It's like a tan of trigonometry, but it is cooler and is more useful. I could have just searched it up. Tanh function, and the definition is a bit daunting to see, to look at. A lot of exponential, but what it basically do is any value at 0 is 0, any value getting closer to infinity, it's getting closer to 1, and vice versa, -1 at the end. So it's like, it's kind of clipping your input. It's not really actually a clip, I'm not sure what's the term for that, but the precision of our program, because it is a computer, it cannot do math very good. You see, 3 plus 5 is 8, and 8 feed into tanh should be something very close to 1, but it just write 1 for you because it's too lazy to calculate all of those numbers. But anyway, this is what it is, and it is very useful in the machine learning and deep learning stuff. So I'm gonna create something a bit more useful than this. I'm gonna write a single layers of a neural network. So if I go here, how do I delete all of this? Okay, so a single layer of a neural network, basically you have one input, you call it X, and you have two different parameters called weight and bias. So this too is a parameter. What it basically means is also an input, but the thing is you can update it. It will be updated when you train the model, and then you hope that the newer version of these two parameters will get better, produce less error in the output. So what you're gonna do with this, all three number, you multiply W with X, matrix multiplication, and then you add bias. And the reason we do this, because W is a matrix, it's not a single number like we see here. So it is a matrix of, for example, A, B, C, F. And then X is a vector. And you have it, let's call it Roman numeral, for example. And then you do matrix multiplication on it. And then B must be 3 element. So I'm gonna use big number, a big alphabetic character, and you add it. The reason, because, no, I've done this wrong. I'm doing it wrong. I'm so sorry. Gotta redo it. Matrix should be in this form instead, because our input is 2 element. So the matrix should be 3 by 2. The reason it's 3 by 2 is because when you do the multiplication, this thing should be stacked on top. So I got I here and 2i like that. You multiply each element and then you add them together, and then you do the same for the second one, for the third one. It's simple algebra, is it? Yeah, algebra. So it's linear algebra, so if you don't know anything, please learn. And why am I doing this? Why am I explaining this? When you do this, you get a 3 element vector, and that 3 element vector will be add to this things over here. So it has the same number of elements, and what it basically represents is that the input you have is 2 node, and the output is 3 node. That's what basically all of this mean. The input 2 node, you have 2 number, and then the output you have 3 node. So after you do all of this, you get another vector of 3 element, and then that represent the output or the hidden layer or anything after that. And all of this number represent each of this connection between layers, input and output. I'm not sure if you follow, but that is what it basically means. I did a video about the entire thing, I think. I don't think I get into matrix multiplication or anything. But if you haven't watched it yet, why not? Should do it now. The video is not that good anyway, but what am I saying? Anyway, you do matrix multiplication, you add it, and then you pass it into a function. And that function is, there's a lot of choice for it. They call it activation function. Activation function. And the tanh function is one of the example. And there's another function called ReLU, sigmoid. Those are the activation function, and it basically break the linearity. This multiplication and addition, it is linear. It doesn't do anything to your input. If your input increase by, let's say, 5, the output also increase by a factor of something multiplied with that 5. It doesn't change the factor. The factor stay the same. So it doesn't go increase like an exponential stuff. It basically go linear. And there's more into it, not just simply increasing or decreasing, as I said. And it is a bit more complicated than that, but basically all of this function do is break that linearity and make it a bit more non-linear basically, so that it can fit with a lot of input, fit with different type of problem. the parameter, of course. So I just made the thing more complicated, but no one gonna watch this video, and I'm gonna be here alone typing my function. So I'm gonna use ReLU for the input, for the first layer, and then the ReLU take in the addition, and the addition take in the multiplication of W and X, and then another parameter of the addition is bias B. Can remove this. Now I can define it in here, basically what is W and what is B and X. So I'm gonna define it using, give it a random value. So the weights value should be, so what is our model? What are we gonna do is try to define what is the shape of our model. In this case, the model is 2 and then 3. There's nothing in between. So what I want for our model is a single input, and then let me check the stream real quick, make sure I'm still speaking. Okay, a single input, and the hidden layer should be like say 10, another 10, and then a single output. This is a simple regression model that we're gonna build here. It's nothing complicated. So it take one input in, and then it got 10 output out for the hidden layer, and then it take another 10 and produce 10 again, take another 10, produce 1. So we have a 3-layer model, 4 including the input. But what we can do is, so I'm gonna define the input in our function here, X. I do not like Copilot in this situation. It's keep suggesting stuff that I don't like. Our node is a simple scalar. And I'm gonna give it value of 0, for example. And I forgot to mention each of this layer, the first layer is gonna use ReLU function, the second layer is gonna use ReLU again. I'm gonna explain what ReLU is. The output layer is gonna use let's use 10H, because I'm gonna build this model to predict a simple trigonometry function, sine or cosine. So the output should be just -1 and 1, and this function clip the output to between -1 and 1, so we don't need anything else. And what basically ReLU is a very simple function. If the input is higher than 0, if x is larger than 0, the output is x. Otherwise, it is 1. Otherwise, it is 0. That is what the ReLU is. So it looks like this. You can see the breakpoint over here. I call it the breakpoint because it breaks the linearity. I don't understand what I just said, but anyway, this is ReLU function, ladies and gentlemen. Gotta go back. Client coding, blah blah blah. Now going to use random and give it a matrix. So since the input is 1, the output is 10, it got to be 10 by 1. It's like the opposite, that's what I remember. And then bias should be a random value. And it should be 10 by 1 also, because it is basically a vector of 10's element. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then by 1. Basically, you don't have any other number out here. I can just say 10 in the random. I don't even need 1, just like that, 10. And just to test it out, I'm gonna call this the hidden layer 1, H1. And I'm gonna test it out really quick because it usually didn't work. What is going on with this terminal? Now something wrong. Stream 12, did I save the thing? I did not save the thing. Now it should work. Kaboom. Would you look at that? The reason you see all of this 0 is because ReLU clipped the entire thing. So if the value is negative, it's gone. So I suppose that the addition and the multiplication make it negative, and then ReLU function over here just clip it out and it's gone. Now it worked, and as you can see, it's produced a vector of 10 element in there. It means that our first hidden layer worked. And I could just write the entire model in a single expression function, but it's very long, so I'm gonna use another feature that I created in Nodeflow CPP, C++. I gotta stop saying CPP, which is called subgraph. So I have this graph over here. I can use it inside another graph so that it builds a larger graph basically. And in case you don't know, I got a full documentation on how to use this thing. So if you are interested and want to make your life a lot harder, you can use it. Here is the documentation. That's what I call it, documentation. It's not a documentation, but I call it anyway because it sounds cool. And I forgot a semicolon over here. I'm gonna change it later. But basically, whatever you need for the graph, it is here, I suppose. There may be a bit of stuff I didn't include, but anyway, let's get going. The second layer is also the same. Gonna use ReLU function, and we're gonna use the same principle of neural network. Basically, weights multiply with its input, and then add bias into it. Now we want to use this as a subgraph. We want to use this as a larger graph by include this graph into this graph. So what it basically means is the input of this one, x over here. I don't want to use x. I don't want to give any value into x. I just want to give this function into x. So we compose this thing on top of that h1. So I'm gonna call it $x because I can tell it to use the h1 as a subgraph. Now I'm gonna define the weight and bias first. I'm not sure why my editor look like this. W's. Bro, what is going on with my editor? W is a random between 10s and 10, because this time the hidden layer is from 10 to 10 again. So the matrix gonna be a big 10 by 10 matrix of weights. I'm gonna stop using that. I'm gonna do this instead. And bias is also 10 element. Bias and input is always a vector, and then the matrix, the weight is a matrix. Now here is a cool part where I can include another map, and this map is the subgraph. So I can tell Noteflow C++ that the $x is another graph by passing in the reference to my h1. This is a reference, not a copy. Or to make things a bit more clear, I can pass the pointer so that we don't think it is a copy. I can call the entire thing by call h2.forward.print, and that should call everything from h2 to h1. So let's call it again. Let's run it. Look like it's some value. I'm not sure if it is working or not. Now let's do a bit of a back propagation, taking the derivative of this thing to make sure the things still work, because usually it worked fine, but when I called backward, a thing just turned into crack or something. Oh, it still works. So let's continue create the third layer, which is the output layer. So graph, I'm gonna call it output, doesn't matter what you call it, and this layer take 10h as a function. I really love this function, but it's kind of slow. It's not really slow, it is just relatively slower than other function out there. And we're gonna do the same thing, multiply the weights with the input x and plus b. Now I could basically just copy this because my editor looked like it's about to die or something. I'm not sure. I'm gonna call this output, and the weight for this one is not 10 by 1, it is 1 by 10, and the bias is just 1. So I can just call random like this, give you a single scalar output, scalar number, and I pass in hidden layer 2. Now I can call output.forward. Now basically we have a model here. I could call this output a model instead of output, and basically we done. We got a model. So how are we gonna train this? Now in order to train, you need a master or a PhD in mathematics or something. I'm just kidding. That's a bad joke, because everybody can understand the math behind neural network very easily. So we have a model, we can call forward, and we can print, get the output from it by give it a input. So we're not going to evaluate our model on the input of 0. We want to change the value. So Noteflow C++ allow you to do that by just call h1.setNode, and I'm gonna set the node x here on the first layer, and I'm gonna set it to a different value. So let's say, and it has to be the same shape. Basically 1 by 1 matrices is a scalar right now, and I'm gonna pass in 1. If you change the shape, you gotta reconfigure the entire graph by basically call model.finish. So you call this after you change the shape, but in our case the shape doesn't change, so we don't care about it. Now I call the model I'm gonna evaluate on the input 0 and then change it to 1 and then evaluate again. And let's see if it changed the output or not. Hopefully we get two different answers. Yes. But although the output should not be, oh yeah, so the output is a single number, it is correct, and this one is 0. I'm not sure why. It may be it is negative and it is not supposed to. Oh yeah, I forgot to change it to 10H, that's why. Okay, now it is 10H, it should not be 0. Close to 0 or 1, or maybe sometime it got clipped by the bad math of computer. Anyway, you got some negative number over there, that's great. That means it is working. Now to train the model, we gotta calculate the error, how bad the model is doing, and to do that we need something called dataset. Can I just scroll down? Oh, perfect. Okay. Our model is currently take an input. Let me draw it this way. I really love this diagram. So it take an input and it take in all the parameters that I give, basically random right now. Parameters, basically all the weights and bias 1 and 2 and 3, for all of the layer. And this thing basically produce an output, the prediction. So we call it prediction. Again, I explained this in one of my videos, so check it out. It took so much time to make it, so gotta watch it. Anyway, I just missed my online class a bit late, should be fine. I have another assignment to do. Instead, I'm streaming instead of doing assignment. Anyway, it gives you a prediction based on the parameter and input. Now, we want to tell the model that this prediction is doing good or bad. And to do that, we need to know a proper input, a predetermined input, and a predetermined prediction. So for example, if I pass in an image of an apple, like this, maybe, because I'm not good at drawing. You have an image of an apple, and this image is basically composed of pixels of numbers that represent pixel in the image. So we can pass the entire pixel arrays in a vector into our model, and then with this parameter we can predict, telling whether this is an apple or not, 0 or 1. So basically this thing is a 1 because it is an apple. If you have an image of a car, for example, this is a 0 because it is not an apple. So our output is either 0 or 1. So the predetermined prediction is 1. We tell the model that no, this is not 0, it should be 1. So you gotta calculate your mistake. That's funny. Calculate your mistake. Anyway, it tried to find the difference between its prediction and the correct answer. So the prediction might be 0.6, so it will calculate the difference, and there's a lot of way to do that. One of the most popular one, it's the easiest one to learn, and everybody getting into deep learning will know this, called mean square error, MSE. It's not MSG. It's not the cocaines of food. Did I say it right? Anyway, it's not MSG. It is MSE, mean square errors. But basically, you subtract the target from the output. The output from the target, you square it up. This square, and then if you have more output, in this case just one output, so you don't have to do anything else, and this is the mean square error, and the error will always be positive. start from 0. So the larger it is, the worse the model is doing. So that is the error function. So we're gonna use that. And it is not the entire mean square error because our output is just one, a single output. So, and for the application that we're building to predict a function, mean square error is not good for that. Mean square error should be good for something else, I think. I forgot what is mean square error is good for. Regression. Wait, no, I was wrong. Mean square error is for regression problem, and it is not good for category. I don't know how to say that word. Categorical data. Yeah, this word. It's not good for that problem. It is good for this kind of problem, regression. And what we're building is a regression. So we're gonna use it. And it is not this thing entirely. It is a subset of it. It is not a subset. It is just a simple subtraction and power. So ignore what I just said because I think there's a lot of caffeine in this water. It's just tap water, but I don't know if it. So we're gonna create another graph that take in our model and calculate the error. So to calculate the error, we subtract the target subtract. So I'm gonna call target T and then the output Y, and I use $sign because I'm gonna use this as a subgraph into this. So we don't have to set the value or anything, we just call, and then the Noteflow C++ will automatically propagate it back and call everything that it needs to get the value. So we subtract that and then we raise the power to 2. And what cool thing about Noteflow C++, I need a simpler name. NFCPP. You can just pass in the number, basically. You don't need a variable for this. Just use a constant, my friend. Anyway, I'm gonna define T. You can use setNote to define stuff, but when you do that, you need to call .finish in order to reconfigure the entire graph. But if you do it here, it is automatically set when the graph is created. So the output is basically a single number. So I'm gonna put in 0 for now, and we can set the output the target later. Oh my god. Yeah. Okay, now I'm gonna pass in the model function. The reference to the model. And boom, just like that, you get an error function. It's depend if you know math or not. If you know the mathematics behind it, you can just build it. And the syntax is simple. You don't need to write a bunch of crap to just get a model to run. I mean, you can just do the same thing in Python, but you know Python is slow. So who like Python, where you can just do it in C++, make your life a lot slower by learning C++. Anyway, I'm gonna call error.forward.print. And it is, what it's going to do is, the input is 0 and the prediction and the target should be 0. So before I do the error, I want to call the model dot. Actually, I don't even know. I don't even need to do that. I call this. I don't print it now, but what I can do is I can use the model dot get f dot get value. So what I basically do here is this thing gonna propagate every value backward, so it calculate everything. So that means that the model will also be calculate, and I'm gonna get some value at the end node of the model, and then I can get that model value, the prediction. So this is the prediction. I don't even have to do that. I can just call print, and then for error I can just call print for the error. Now we can have the loss value, the error value, and the prediction at the same time, so that we know if it is legit or not. So I'm gonna call it here. It is simple. See, who want to do it in Python, right? You can just do it in here. Okay, here is our prediction, 0.52805. 0.52805, and the target right now is 0 over here, so I'm gonna type in 0. Let's do some math, ladies and gentlemen. This entire thing is 0. Wait, what did I just do? I subtract target from the prediction. Okay. You need who need calculator? You can just do mental math on a paper. It's not mental anymore. 9. What is it? 1 7 1 4. No, this is a smaller number. I gotta do this instead. 0.52805, 0.000. Basically, you got the same number. Yeah, 5 2. Yeah, you got the same thing, and then you squared it up. Okay, now I'm not going to do that. I'm gonna use some online calculator. 0.52805. 0.2788. Boom. Look at that. Awesome, don't you think? Now, I'm gonna close this terminal. Now we get the error value. What are we gonna do next? After we get the error value, I don't even need to do that. I don't even need to call the forward. I can just do the back propagation based on the input by calling error.backward. And this, it give me it go backward, and it calculate all the derivative of this error function with respect to each and every single input. Basically the weight and bias and input. So what I can do is I can put this as a constant so that it don't take the derivative with respect to this input over here. Save us some time. It's not much, but I'm just gonna do it anyway to show you how cool my library is. But that is basically what you can do. Now you can get all the partial derivative of the entire error function with respect to each and every single w and b in here. So what it basically means is that the error function is a big function that takes smaller function, and what it basically do is one of those function will eventually take in the value weight and bias value, the parameter. And when you take the derivative, for example, partial derivative of the error with respect to weight, for example, it tells you how much the error would change if you increase this weight by a little bit. Now, if you know how much the error would change when you increase this, you can subtract that value from the original weight. But before we do that, we multiply this thing with something called the learning rate, and it represented by this letter end with a long leg over here. We multiply with a small number and then we subtract from the original parameter. Now we get a new parameter. This gives you new parameter. And this new parameter hopefully will reduce the error. And you do this for all of the parameter, the weights and bias value, and then update it to get a better result. Now I just realized something else that we need to do to make sure that our library is looking cool is that target is also a constant. We're not going to take derivative with respect to that. And 2 is also a constant, so it's already a constant. After we do the backward, I can basically go to each and every single one of the layer. Let's start from h1 dot get grad with respect to w, and then I'm gonna multiply it with the learning rate. So I'm gonna define it in here, learning rate 0.1 maybe, and then I multiply it with here. The get grad return an eigenmatrix, not a real mathematical eigenmatrix. It is a library in C++ that I use to represent matrices. So it's basically give you a matrix. Now that matrix, I suppose I can multiply it directly with the learning rate. Let's do that and then test it out by print it out. I think we need a better way to do this, because I don't want, oh no. Okay, I don't suppose I can multiply like that. I have to use dot array or something, but I'm gonna test it out to make sure that this thing gives you a proper output. Okay, it's not output. Invalid matrix product. Bruh. What is going on? Okay, so there's something wrong. Let me check the model backward first. It might be the shape of the target or something. Now I'm just, I hate programming again. Should join my online class real quick. Life is good. Where is the D2L?
From Reese saying, I didn't think a moment like this was going to happen, she says, cradling Pepper, the French bulldog, in her arms. We're not there yet, but I lay down and dream of all this stuff, Stepner. I lay down and dream of all this.
Okay, I'm back. Okay, you can still hear me. Huh? What just happened? The class already end? Oh, it's a video. It's funny. Anyway, guess it's somewhere in here. Okay, I'm not sure what is going on. I'm gonna try from the hidden. Okay, now I don't know what's going on. I think because the constant. I think the constant is not working. No, the constant work, but yeah, I need to do this maybe. Gotta put it back as a constant. No, what is going on, my friend? H1.forward. Huh? No, I'm using the icon library so much because the error doesn't mean anything. I should have write my own error handler in the library so I know what's going on, but too late now, I guess. It worked a moment ago, don't you think? Was it? Do not understand. I don't like C++. It is just an excuse to say that. Bruh. What's happened? It worked. I hate this thing so much. Oh no. Don't make un. Cannot just print. Oh my god. Now it worked. Bruh, what? I think it's because the forward, I need to forward it up or something. It's not supposed to act that now. Yeah. So the forward, what I did in the library, so it actually helped set up something. This one, no. This one, yep. It helps set up with the shape of the value, the shape of the node. This thing is used to avoid repetition, because sometimes the node can use in multiple graph. So if it is already calculated, we don't have to call it again. We can just get the value from it. I don't see the set shape. It's a oh wait. It might be. Oh my god, it might be because of the multiplication here, over here. This is a big problem. The error should be in the value, I think. Let's check. I don't want to debug it now because I have assignment and everything to do. Put it back. Let's do it anyway. So it has some value in there. It called the first one, but then the second one should be the addition, I think. So the error occur in the value, no, in the addition. Move this up. Okay, I'm back. Cwise binary op.h line blah 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 blah. Yeah, I can check it out. Where is it? Eigen source core Cwise binary operator. God, there's a lot of this. Oh, 118. All right, where are we? Oh my God, what is this? What is this trait? Russ? Wait, it has an error on rows? By calling rows, give me an error? I don't suppose it is. Should be this one. Require size to match, of course. So the size is not matching. I suppose there's some problem with that. It's because I pass in a scalar. That might be the problem. But okay, it's the value. So no, just give me something. It should give me. It is here, and I suppose that value call yeah, the value call, but I suppose that that is where it stops, so I'm gonna go to addition next. Somehow you need to call the forward just to use the backward. That's not acceptable. That's not my design. Yep, it's value, my guy. Ladies and gentlemen, we got him. So it is here. So the problem, we cast the array. Let's just call the outer derivative first. You have another assignment again. Yeah, I do have this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait. Oh, it is here. Okay, it's supposed to. It is 10. Okay. Doesn't have the input. Oh yeah. Supposed to call the forward just to get the input because the input is important. Because this thing uses the input for some reason. It's not supposed to use the input, everybody. ReLU. So it's like max. The thing is like this, so what does the other derivative do? The derivative of log e is also use input. Yeah, I suppose we need the input anyway. So it is me who have the problem with myself. I need to call the forward in order to use the backward, because derivative of some function, it need the input. Of course, every derivative of the function need an input, because some function can use the output directly, but if you don't call the forward, we still don't have the value for the backward anyway. So here is what we gotta do. We gotta call error.forward. Gotta do this. Do that. Gotta do that. Do that. Boop, 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 boop. Horrible mistake. Just waste the entire. Okay, I'm back over here. Okay, we're back, ladies and gentlemen. Multiply with the learning rate. Now it should work because I called the forward. But last time I did call the forward. Now I don't understand again. Core product. What does it even mean? Huh? What is going on? What is going on in here? It worked and it didn't work again. I think I have to stop the stream. I cannot stay over here. Gotta try. God damn it. Huh? No. What is going on? The hash? Okay, the hash is the one to make it the... Bro, what? The constant? There's no way the constant. I don't think it is working properly. I gotta change the documentation. No way, no way. h1.constant. Gotta do that instead. There's a different way to do it. Of course. Okay, change your plan. To make things a constant, just use dot constant. Don't be too lazy. Just do that. That's how you make life a lot easier. Instead of doing that, we're gonna use error dot. This constant doesn't mean that you cannot change the value of the thing. You can still change the value, but the derivative does not care about it. That's what it basically do. Now let's see if it's still working. There we go. But why is it 0? I don't know what is going on. Just give me some value, but whew. I'm gonna call the model instead of this thing. There. I think it's because the value is the one making it 0 all the way. Maybe, yeah, maybe it is. If I use the model, I call W of the model instead, it would not be 0. Yep. Is it that? Did I save it? Rerun it again. Where is the new line, my guy? Okay. Does seem to work anyway. Anyway, guys, anyway. Multiply this with the learning rate. Oh, I can do this. It's funny. That's not what I want. Call the model dot. Oh, I can call update. That's awesome. Instead of set. Oh, Copilot understand what I was doing. This is not what I want. This look horrible. Who wrote this code? We need a better way to update this. Don't like this thing. What can I do it better? What can I do? Model.get. Okay, it's fine. Get grad. It all seemed fine. It's just not clean. Chat, it's not chat, it's Copilot have a better idea previously. But I don't think I can do that. It's all the same. It doesn't matter. It doesn't make any difference. Oh, of course, there's gonna be an error. Gotta do it one by one. Oh, now now it worked. Check this one out. So, oh, okay, because I use the model parameter to update the hidden layer. The output should be output, not model. Yep. Okay, we updated this learning rate. I'm just gonna call it a few more times. Gotta do this. Put it here. So it should call this forward and then call backward. So I'm gonna do the print, and I'm gonna call for no, not let, that JavaScript. What am I doing here? Call it 10 times and see if the error getting lower. Okay. Let's see. Oh, the I forgot what I did. Oh, taking attendance. That's great. Okay, attendance is over. We're getting back, so the error seems to be here. I am not sure why. Oh, no. The error is not there. Oh, why? So, it seemed to work even I just update a single layer parameter. The rest I just keep it that way. And anyway, the error getting low very quick, like insanely quick. Look at that. Previously I update only one layers and it get 10 iteration to get to 0 0 0 1, and this time we just need 5, and then the rest just getting down like insane. But it doesn't mean that the model will do any better with complex data set. In this case, the data set is not even changing. It's just 0 and 0. The input is 0, the output, the target is 0. So let's say we want to update, let's make it better. Let's make it different. So gonna create a data set, and I forgot how to do that. Let's do it together. Vector double. I think I can use something like iota. This should it's like a list generators or something. I'm not sure how to use it, but I heard it somewhere. It is good. I was going to post a blog, an article or something about the library, but the library is a garbage. It's not working yet, so we gotta ignore that. Okay, iota, take in numbers. Doesn't return anything. X. I'm gonna create around 50. Let's 100 instead. And I'm gonna do iota because I do that. X plus 100. What is ST? No, this is not correct. I need a better way to create an array. I did that with matplotlib, but I forgot how to do it here. It's gonna include numeric. I can just tell Copilot to do it. I don't pay money to just let it be there. Ax from 0 to 2 pi for how much? 100 element. Oh, let's use for loop. Define the Okay, now we got it. We got the value and everything. We go to I 100. Hopefully we get, where did got a sign come from? Oh, I did include CMath. Let's run it to make sure it is working. Okay, it is working. This is awesome. Um, 10 iteration. Each iteration we go through the data set. We set x to x, and this is not correct. And we're not supposed to create a new value either. We gotta do this instead. We gotta use get note x forgot the API thing I created. Where is set value, new value of the eigen matrix? I can access the operator using this operator thing, using index. And why there's only one double? Why do I do that? What a mistake. What a horrible mistake. Dot get node. Or maybe I can access the eigenvector directly. Get matrix from graph using h1.get. And then update. Should be 0, not 1. Or that's not the way it goes. It doesn't understand my code, bro. Come on, understand my code. I do have a get value, do I? Yep. Give me the eigenvector. Eigenmatrices. Eigenmatrix xd double. So in that case, I can get the eigen, and I can do this. Use the operator on it directly. That, I suppose, will work. Comment this out real quick and test stuff. What is it? H1 dot model dot forward and test it out. That's why you're not going to spend your time developing a library where you can just use some other library out there. Okay. Awesome. Uncomment this. Close the bracket. h1.get, set it to x. Why do I set this? Bro, what are you thinking? Yeah, that's smart. Okay, so I set the input and target, and then I call the forward, and then I call the backward, and hopefully it will train. Gotta be a lot number in the output. Ooh, look at that. Ooh, the error is very small. No, I cannot read this too much. It's 100 of them. So instead of doing this, since the value is only 0 by 0, 1 by 1, I can access it, call it double. Damn, that's smart. Edit, and then divide it by 100 or something. See out it. Oh, Copilot. That's why you gotta pay for AI to take your job, you know. Would you look at that? It doesn't seem to understand though. The output, the loss instantly get to very low number. So it might be some problem. If it seemed too good to be true, it is too good to be true. It is not good. That's what I'm trying to say. One thing I'm afraid it might be the problem is might be the dataset itself. It's not clean. It's not properly created. That might be the reason. It is created properly. What am I saying? I'm having a doubt on Copilot. So sines of pi over 2, 3 divided by 2, 1.5, 1 point something. Should be here close to 1. Yeah. So I got the value. The only problem is, damn, it seemed too good to be true. I'll call it one more time. Maybe it is good. This time I don't have to call the error to get the target value. I just need to get to set the input, and then I calculate the error. I don't even need to calculate the error or anything. Let us just see out forward. Ooh, this is awesome. Anyway, input, output, prediction. Drum roll. What the hell is this? It's negative. And how did it just calculate the loss so low if the output is not even close? Look at the loss. This is disgusting. 0, 0, and then the output is I'm gonna try to run this without updating the parameter, because it's my overfitting, underfitting the term I don't understand, and it just crashed the entire thing. Would you look at that? Beautiful. Did you get 0 point that? Oh, yeah. I use gradient descent, not stochastic, not the drunk man. I should use the drunk man to update the thing. So all of this should not be like that. Instead of immediately update all of this, I should sum them all up and then update it later as a batch. Okay. So I can oh, this is not good. This is horrible. I should create a new time one. Yep. Okay. It does know what I'm trying to do. So after that, it doesn't multiply with the learning rate though. It should multiply with the learning rate in order to get grad. Oof. I'm gonna multiply the learning rate myself. Now, instead of doing this, like that. Like that. Oh, I have to divide it. I have to average it up. Now it just looks like crack. It's not a clean thing anymore. Oh, no. Good. Gonna try to see out it and break it first before it run into anything else. Where is the value? Give me the value. Here. Ooh, the hell is that? negative to the power. Ooh, that is a very negative number. This thing's supposed to be 0. It's supposed to be a constant. Yeah. Yeah. That. 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 Okay. Still gonna be some random stupid number. Oh, now it's a 0, bro. Bro, what are you doing? H will not get grad. W multiply with the learning rate. Should give me something, but it doesn't. For some reason. I divided by 100. Maybe this is the problem. Should move on with my life, doing something else, make a video game or something. Now I hate this thing at the bottom. And we will not intolerate stupid cout. It doesn't make any sense. Okay, now I understand, because the thing is always 0, so it's cout b. Oh no. This is not a good thing. That is a lot of 0. The target is 0, so I'm gonna put in B. No way. Did not save it. This is how I debug my program, guys. It does have a value and it does change over time. Oh, this is not a good thing. Oh, this is not good. Oh. It's supposed to be by batches. It's not supposed to be the entire things. If j divided by 10 call let's ignore that because it doesn't make any sense to do so. Gradient descent should work without having to deal with anything at all. So I'm gonna put it back where it's belong, minus learning rate multiply dot get gradient. Where did you get it from? So I'm gonna update the weights value. Oh, the learning rate is a bit too high, I think. Yeah, now it seems a bit more reasonable in my opinion. A lot more reasonable. Make it slow. Boom, would you look at that? It is clean. Now we update B. I'm just gonna use PyTorch. After this, H2, H1, yes sir. Doesn't shoot out of the roof like last time. Now this is where I can draw my graph at the end. I can call them std vector double pdict 100. And this is where I will set my P in here. And then we can draw it, but I don't have a library to draw. So we gotta figure out how to install that by spending a few more hours to do so. Alright, let's get started. CPP matplotlib. As I remember, there might be matplot++. That is what I'm looking for. This is where it is. Yes sir. Yes sir. Clone the whole project. That's what it does. I'm gonna clone it in test. Add subdirectory in here. Matplot ++, and then add the executable and then link to the matplot. Target link library. I'm gonna link the second one. Can I do it multiple line, or should I do it in the same line? Where is the error? Give me the error. Just give it to me. Dependency class is not found. What does it mean? What is it? No flow test. All use of target link. Yeah, have to be the same thing. That is taking a bit of time. Oh. Oh. The hell is that? Four. What did I do wrong? It worked last. What the hell is this? Okay. Worked perfectly. First try. If you don't believe that. My plot. H. X and Y. Hold on. X and P and show. Hold on, wait a minute. Where is my graph? Give me my graph. Oh, I forgot to run it. That's why. Oh, check it out, drum roll. Oh, oh. Now I'm so disappointed. The hell is this? Is this the optimization? The optimized version of it? This is so disappointed. What the hell? I guess the loss is low. It's like a big oh, it might be this. No node method. Here it is. Get node. Set node. Let's get operator node. Get value. This is what I want. I could just done that a very long time ago. Oh no, I cannot do that because it is the end. Here I can use the output instead. Get output. So it's supposed to be 0. Wait, where is my... It did not run this thing. it is still the old code. Oh. Because I forgot to run. Forgot to compile. 75 is a problem. Cannot convert from matrix to... Okay. Hold on. This should work. This would be the last time I'm doing this. It is still not working. I'm coming back. I'm doing this. I'm still doing it until it works. Got some very low value. Very low values. I don't understand. I'm gonna come here. That doesn't make any sense. And why the loss value getting so low? It's like it lost the ability to do so. The prediction getting low too. Okay, so we were trying to reduce the error, not the prediction. Yeah, the function is correct. Use absolute. I don't have an absolute function. What does it reduce then? Is it the target? It's not. The target is not even changing anything? Give me y. Don't give me y. Give me the target. Get t. This is awesome. T have never been changed. I thought I changed it here, and it did nothing. The hell? It did not do anything. Oh, just create a new thing. Just ignore this. Instead of doing that, I'm gonna call get set node x colon create a new node, whatever. Immutability is the way to go. My people. That's why TensorFlow doesn't allow you to mutate any value. Yes, that's why mutation is the cause of I don't know what I'm trying to say. Watching too much X-Men movie recently. Oh, what? The hell is this? Oh yeah, because I'm stupid and I don't have a life beyond programming. Boom! Would you look at that? It's only been like, what, 2,000 tries? Ho ho. Do not dare talking to me. How do I do this anymore? Use of undeclare identifier X. I was declaring X and this guy is telling me that I'm using it. Undeclare. Okay, I'm gonna change the learning rate to a bit higher and hopefully it's gonna make something a little nicer, you know, a little more fit in. Then I should stop talking about X-Men. Fit in? Would you look at that? Oof, beautiful. That's not good yet. That's not good yet. This is only 10 iteration. Would you look at that? I mean, the source of a good training algorithm is not the language itself, it's the optimizer. So this doesn't prove that my library is good. It just no good. Oh, higher learning rate is horrible. Oh, it doesn't get any lower. Let's make it higher, my gentlemen and ladies and boys, please. Oh, look at that speed. Would you look at that speed? Still not happy with this. You always want more, you know. It does keep decreasing. It's not overfitting or anything. Underfeeding. I'm gonna change this to 10H. Who gonna tell me what to do? I'm gonna tell myself what to do because I don't know what to do. I suppose it's gonna take a bit longer, but oh, that's still fast. This is fast. This is fast. Super. What if I change the function to something else rather than sine function as it use cos? I want to do 50 iteration and that is already there. Ooh. Yeah, it's the source, it's the data set itself might defect. I suppose the 10 function will crash everything. tangent. Oh, it's not working. What the hell is this? Let's go back to sine, and then this time, instead of 50, I'm gonna call it 100, and then make the learning rate a lot lower. That might not be a good thing. I need a better way to update the value of a node, because there's too many layers of abstraction. So if I want to set something, the thing in there is, it's like I have to get down so low to get something like this line over here. I have to get f, I get value, and then access 0, 0 to just to get a single double number, which is not convenient. We need something better. And same thing to updating the value. I will have to do this, do that, which is not good. It is not, it's always not good. But I was trying to avoid redundancy and creating too many stuff, rather than like what am I saying? I'm trying to use mutability and reusability. That's what this library is about. But instead, it doesn't work because I'm a stupid guy. I use some random eigenvector, eigenmatrices to do so, that I don't understand much. And now it's haunting me. And we don't have any better optimizer than this gradient descent. Ada, maybe? That might take a long time to implement. Okay. Then we should set the node down over here. Let's meet each other later in the future. What else can I do? 100 iteration. The learning rate is already we already changed the learning rate and everything. Yeah. Now there's a lot of problem out to fix. The bug one is the constant. Setting it a constant make the entire thing crash when I try to use backward by using this expression. Make it crash. So I have to fix that. And the other one is accessing and setting the value of a matrix or a vector or a scalar by avoiding recreating node. The node should just exist and then we change the value, not changing the node itself. That's not ideal. Maybe we can try a different function, like random. Oh, Perlin noise random, that would be nice. Not good. Instead of, yeah, I don't know. You just use x square, xi. It's not any cleaner than the its competitor. Competitor. Oh, the loss doesn't get lower. Oh, it's because the function clipped the entire thing. In this case, we can use ReLU because the ReLU it's not restricting anything above positive, above 0. Wow, doesn't make any sense. Always says that. Oh, we can change the shape of our layers and everything. Make it more layer, and that will hopefully better. What's the problem here? I squared it up. The loss does seem to get lower, but couldn't get any lower. Maybe the value is getting too high. Let's go back to sine. Anyway, I'm gonna change the shape, make it nice and clean. Make it more. Make it hidden layer 3. This thing use hidden layer 3 to do so. And when we update here, that should be everything. Okay. Oh no, I have to change the activation function back. 0.5? Yeah, it's because the activation function is trash. No, not that. This is the activation function. I'm gonna use the absolute value, but I don't have the absolute operator in here. It's only, do I? I don't think so. Oh yeah, more layer obviously do better. I suppose that if there is more layers, the higher the learning rate wouldn't do much to it. Yeah. Oh, but it quickly going overfitting. 0.5. Yeah, it's getting overfitting because of this. What if we do it more node? Let's say 20. Let's go all in with this and see how long will it take. Anywhere else indicating that I need to change something else? No? Not at all. Let's keep going. Okay. It doesn't help. Maybe we need a bit more iteration, let's say 500. Wouldn't do any much. do it like this. Oh, it is very slow. Oh, it's getting. Oh, would you look at that? 4, 3. Now it's stuck. Oh, this is clean. This is nice. Why would you use TensorFlow while you can just spend 3 years developing your own library so that you can build a thing in what? Let's see. 3 hours. Why would you do that? Why would you spend 5 minutes in TensorFlow when you can just do it here with 3 hours? That's hilarious. Anyway, I gotta stop it. Gotta stop it. Couldn't do it anymore. Still have assignment to do. Okay. Have to say goodbye.